Hearty welcome once again to the Math Revision Made Meticulous video series. Topic Determinants. In this video we will see problems on determinants, adjoint and inverse of a matrix. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Now let us see how a determinant is defined. Now we will consider the system of equation which you already studied in class 10. a1x plus b1y plus c is equal to c1 and a2x plus b2 is equal to c2. Now the system of equation has unique solution only if a1 by a2 is not equal to b1 by b2, which implies when you cross multiply a1 b2 minus a2 b1 is not equal to 0. Now this value a1 b2 minus a2 b1, which determines the uniqueness of the solution, is associated with the matrix a1 b1 a2 b2. They are all nothing but the coefficient matrix, is called the determinant of A. The number a1 b2 minus a2 b1, which determines the uniqueness of the solution, it determines, therefore it is a determinant. Well, now we will define a determinant now. To every square matrix of order n, we can associate a number, it may be either real or complex, called determinant of the square matrix, where aij is the ijth element in the ith row and the jth column. If a is equal to ab, then the determinant is denoted by determinant abcd, denoted by det of a, determinant of a. Now we have to evaluate the determinant for every matrix, that is every square matrix. So let us, for matrix A, determinant A is read as determinant of A and not modulus of A. You should be very careful. And only square matrices have determinants. This also you should remember. And let us now start with determinant of a matrix of order 1. For if you have A, then the matrix of order 1, the determinant A is defined to be equal to A. Very simple. Suppose you have determinants of a matrix of order 2, then it will be defined as a1 a2 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 a21 a22. It is written as a11 into a2 minus a21 into a12. Let us visualize it now. The elements a11 and a22 are multiplied. Then the elements a21 and a12 are multiplied, they are subtracted. You should be very careful with that. a11 multiplied with a22 minus of a21 multiplied with a12. Please be careful with the direction. Well, for order 2, let us now try to get the value of it. So what you have to do now? 5 into 3 you have to find, and I have to find 2 into 3. Therefore 5 into 3 minus 2 into 3, therefore 15 minus 6, the answer is 9. Now let us take another determinant where you have to be very careful with minus of minus. But this will be 3 minus 4. Therefore 1 into 3 minus of 2 into minus 2. Therefore 3 plus 4, the answer is 7. Let us take another determinant where the values are all variables. X square, x and x minus 1. You have to cross multiply x into x minus 1 minus of x into x square. Therefore the answer is x square minus x cube. If you take any determinant having trigonometric ratios, cos theta and cos theta into cos theta minus sin theta into sin theta. Therefore cos square theta minus sin square theta. Well, now let us go to a determinant of order 3. If it is order 3, it can be determined by expressing it in terms of second order determinants. This is known as expansion of a determinant along a row or column. There are 6 ways of expanding a determinant of order 3. First row, second row, third row, or first column, second column, third column. 3 plus 3, there are 6 ways. Now how to do it now, let us see. There are 6 ways of expanding a determinant corresponding to each of the 3 rows and 3 columns. They will give the same value. It is left to you to select which row you are selecting to expand. Now along the first row, let us see. If you want to expand it through the first row, then what you have to do? Multiply the first element of the first row by minus 1 whole power 1 plus 1. Why it is minus 1 whole power 1 plus 1? Because it is a11. and with the second order determinant obtained by deleting the element of the first row and the column of A11 lies. You have to remove the row in which A11 lies and remove the column in which A11 lies and then multiply that particular 2 cross 2. What you have to do now? You have to remove the row in which A11 lies, the row in which column in which A11 lies. What will you get? You will get minus 1 whole power 1 plus 1 into A11 into the 2 cross 2 determinant. Already we have seen how to expand the 2 cross 2. You know how to get the value of this. Let us now go to the next step 2. In step 2, what you have to do? We have to take that A12 to be multiplied by minus 1 whole power 1 plus 2. Why it is minus 1 whole power 1 plus 2? Because it is A12. Sum of suffixes in A12 and the second order determinant obtained by deleting the row in which A12 lies and the column in which A12 lies. You have to remove it. What you are getting? You are getting a 2 cross 2 determinant that should be written like this. Minus 1 whole power 1 plus 2 into A12 into the 2 cross 2. Similarly, go to the third element now, that is step 3. You have to take A13 multiplied with minus 1 whole power 1 plus 3 and with the second order determinant obtained by removing the row in which A13 lies and the column in which A13 lies. It will come like this. What you have to do now? You have to add all these values now. That will be the value of the determinant. Already I have calculated minus 1 whole power 1 plus 1 A11 into the 2 cross 2, minus 1 whole power 1 plus 2 into A12 in the 2 cross 2, minus 1 whole power 1 plus 3 into A13 into the 2 cross 2. I have to add all of them. That is the value of the determinant. Now, then it is easier, it is always easier for us to expand the determinant along that row or column which contain maximum number of zeros. It is left to you because 0 into something, no need to calculate. That is why we normally want to select it, but be careful. If you are confident, you can take any row or any column. While expanding, instead of multiplying by minus 1 whole power I plus j, we can multiply by plus 1 or minus 1 according to it is even or odd. You are seeing over here A11 multiplied by a positive 1. If it is A12, it will be negative. A13 positive. A21 negative, positive, negative, positive, negative, positive. For whenever you are doing with any column or row, you should first fix that sign, then that element multiply by a 2 cross 2 determinant obtained by removing the row or column. Let us go to one question now. This is a question now. Let us see how we can do it now. Expand along the first row. I am taking the first row. Therefore, I have to remove 1 multiplied by a 2 cross 2 determinant obtained by removing the first row and first column, where I am getting it. Again, I have to multiply by minus 2 multiplied by a 2 cross 2 determinant obtained by removing the first row and the second column. You got it. Again, 4 multiplied by a 2 cross 2 determinant obtained by removing the first row and the third column. You got it now. Or simply expand it and you will get the final answer. Be careful while you are doing calculation. Minus into minus, then negative into positive, like that you should be a bit careful. Final answer is minus 27. Well, now let us go to questions now. In questions, normally it will be a problem where you have to expand a 3 cross 2 or 2 cross 2 and get some results out of it. For example, here A is given as a 3 cross 3 matrix. You have to show that determinant of 3A is equal to 27 into determinant A. It is a property actually of determinants. A is given. As the first column has 2 zeros, we will expand the determinant along the first column. There is no need. First column is having so many zeros, that's why I am selecting it. You can select the third column also. You can select the first row also, or if you are going to get the same answer. Well, I am taking it A multiplied by 1 into a 2 cross 2 obtained by removing the first row and the first column. It is 1, 2, 0, 4. Now minus 0 is in the second row. Therefore, you have to remove the second row and the first column, where you will get 0, 1, 0, 4. Plus 0 is it is in the third row, first column. Therefore, remove the third row and remove the first column. It will become 0, 1, 1, 2. Therefore, the final answer you are getting it as 4. Therefore, now we want 27 into determinant A. It is 108. That is the right hand side I have found. Now I have to find 3A. What is the meaning of 3A? All of you know this is nothing but scalar multiple of a matrix. Therefore, I got it as 303, 036, 0012. Once again, I will expand it. I will expand it once again with respect to the first column. 3 into a 2 cross 2 minus 0 into 2 cross 2 plus 0 into 2 cross 2. I am getting the answer as 108. Therefore, I conclude that 3 into determinant A is same as magnitude of is nothing but 108. Therefore, determinant 3A is equal to 27 into determinant A. Why it is happening like that? Because 3 will come out from all the elements, therefore 3 cube it will become, therefore it is coming as 27. Anyway, now let us go to the next question, where determinant is given as a problem involving trigonometric functions. We have to show that the value of the determinant lies between 2 and 4 after expanding. Let us try to expand it now. I am expanding it with respect to the first row, 1 multiplied by a 2 cross 2 minus sin x into multiplied by a 2 cross 2 plus 1 into a 2 cross 2 determinant multiplied by removing the first row and the third column. I am expanding it, normal expansion. I am getting it as 1 plus sin square x plus sin square x plus 1. Let us continue. It will come out as 2 plus 2 sin square x. The final answer is 2 plus 2 sin square x. But all of you know sin x lies between minus 1 and 1. Therefore, sin square x lies between 0 and 1. And when you multiply 2, then it will be 0 less than or equal to sin square x less than or equal to 2. I am multiplying throughout this inequality by 2. Now I am adding 2. It will become 2 plus sin square x will lie between 2 and 4. Therefore, you have proved it. Therefore, the value of the determinant, whatever the value of x you are giving, it will always lie between 2 and 4. Let us go to another idea, minor. What do you mean by minor? Here actually what we did in expanding the determinant, you removed a column and a row and you got a 2 cross 2. Those 2 cross 2 determinant which you obtained while you are calculating a determinant, they are nothing but minors. Let us see. Minors of an element is the determinant obtained by deleting the ith row and the jth column in which element lies. Already we have done it, 3 times we have done it. Anyway, minor is denoted by Mij. Now minor of an element, it is for example if you are having it, for example minor of A11, how to get it? Remove it, then you will get A22, A23, A32 and A33. Now how to get the minor of A12? Remove the row in which it lies, remove the column in which it lies, you will end up with a 2 cross 2. How to get the minor of A13? Oh, remove the row in which it lies, remove the column in which it lies, you will get it. Like that, all the elements, the 9 elements will have their own minors. Let us see what do you mean by cofactors. Now already we have seen that what do you mean by a minor. Cofactor is denoted by Aij, is defined by minus 1 whole power I plus bi of Mij. Now if you add one minor is a determinant, it will have a value. If you attach an appropriate sign to it, either it is positive or negative based on its position, it is called a cofactor. Minor is a 2 cross 2 determinant obtained by removing a row in which your element lies and a column in which that element lies. If you expand it, you will get one value. That value, when you attach a appropriate sign, it will become the cofactor. Well, this is the element I am taking. Cofactor of A11 will be minus 1 whole power 1 plus 1. All of you know 1 plus 1 because it is A11. Now you got it now. Then for A12, its minor will have a negative. For A13, it will be positive. Positive, negative and positive. Well, now let us move on to the next idea. Value of the determinant and cofactor. Suppose we have just discussed what do you mean by a minor, what do you mean by a cofactor. But from the cofactors only the value of the determinant is defined. Sum of the product of the elements of any row with the corresponding cofactors. Already we have done it while we are expanding a determinant. We have multiplied the element with its cofactor and we have added. And it can be done in how many different ways, all of you know. Either first row, first column, or second row, second column, third row or third column. There are 6 ways of doing it. Well, value of the determinant and cofactors. Here I have already given you that the determinant A can be obtained in 6 different ways. A11 into its cofactor plus A12 multiplied by its cofactor plus A13 multiplied by cofactor. If you want to take the third row, for example, A third column, for example, A13, then A23 into cofactor, then A33 into its cofactor. There are 6 ways of doing it. It is left to you to select the way which is convenient to you. Aij is the element and capital Aij is the cofactor. Now adjoint. Now we have defined what do you mean by a minor, we have defined what do you mean by a cofactor. We are now going for the adjoint. Very simple. The adjoint of a square matrix is defined as the transpose of the matrix where Aij is the cofactor. Put the cofactor, get the cofactor matrix, transpose it, you will get the adjoint. Adjoint is denoted by Adj of A. Adjoint is the transpose of cofactor matrix. For example, you are getting this adjoint A, and adjoint A will be the transpose of the cofactor matrix, which will be A11, A21, A31. Very simple. Your job is first to find the cofactors, put it as a matrix, transpose it, you will get adjoint. Good. Now, suppose if you are having a 2 cross 2, getting the adjoint is very simple. The adjoint A of a 2 cross 2 is obtained by interchanging A11 and A22 and by changing sign of A12 and A21. Interchange the elements of the major diagonal and change the sign of the minor diagonal elements. This is very simple. You just interchange and sign change. Interchange and sign change. Okay. For example, you have 1, 3, 4 minus 2. How to get it? 1 and minus 2 are to be interchanged, and 3 and minus 4 are to be done sign change. That's all. It will become minus 2, minus 4, minus 3 and 1. For 2 cross 2, no need to find their cofactors, minors and so on, because its minors will be a singleton matrix. Therefore, we are doing it directly. Well, result on adjoint, very important result on these questions may come. A into adjoint A is equal to adjoint into A is equal to determinant A into I. Very important result. This result actually is useful for finding the inverse of a matrix. Anyway, A into adjoint, adjoint A into A. Only in this all of you are seeing that the product of two matrices is commutative. Product of matrix is normally not commutative, but only for adjoint A into A it is commutative. A into adjoint A is adjoint A into A is determinant A into I. All of you know what is the meaning of that I? It is an identity matrix. If this A is a square matrix of order 2, then I is also will be of order 2. If A is of order 3, I is also will be of order 3. It's a matrix of order n. Then let us go to question number 3. Making use of the idea which we have seen about adjoint, we are going to do it. If A is a non-singular matrix of order 3, prove that adjoint A is equal to determinant A the whole square. This is a famous result. There is a result can be extended for A is a non-singular matrix of order n. Anyway, let us now take A is a non-singular matrix of order 3. Therefore, determinant A is non-zero. Therefore, you are seeing that A into adjoint A is equal to determinant A into I3 into adjoint A into A by a property. Therefore, I have taken A into adjoint A as determinant A into I. Therefore, 1 0 0 0 1 0 0 0 1. Therefore, this determinant A is a scalar. I am bringing it inside. So, it will become determinant A 0 0 0 determinant A 0 0 0 determinant A. Here I am taking the determinant A as a scalar, maybe any real number. Now I am finding the determinant of both the sides. Therefore, A into adjoint A determinant is equal to the right hand side determinant. Therefore, all of you know that in a determinant the idea is you can take the value from first row, you have to take the value from the second row, you have to take from the value from the third row. Be careful, when you take a element from a matrix, only one element will come from all the elements, but in a determinant one value, one common will come from the first row, another common will come from the second row, third common will come from the third row, all will get multiplied outside. But here you are getting that determinant A from the first row, again determinant A from the second row, determinant A from the third row. Therefore, we are finding it the determinant A the whole cube into determinant of that identity matrix. In the left hand side, it is another property of determinant, that is determinant of A into adjoint A is determinant A into adjoint A. For you are seeing that on the right hand side it is determinant A cube into 1, because determinant value of an identity matrix is 1. That is why it is identity matrix. Therefore, determinant A is non-zero. Already we have proved that, because it is a non-singular matrix, but we can divide both sides, but you will get adjoint A is equal to determinant A into whole square. Suppose if it is of order 4, it will become A power 3. Anyway, Now this is a question where we have applied the property of adjoint. Let us move on to the next question, where before we go for that, we will just see what do you mean by singular and non-singular matrices. A matrix, square matrix is said to be singular if its determinant value is 0, and it should be non-singular if determinant value is non-zero. That's all. Okay, singular and non-singular matrix of same order, then AB and BA are also non-singular. We know that if A and B are non-singular, then AB and BA are also non-singular. The determinant of the product of two matrices is same as the product of the respective determinant. These two conditions we have to remember so that we can do problems. Okay. Now let us go to the inverse of a matrix. A square matrix A is invertible only if it is non-singular. The meaning is if determinant A is non-zero only, we can find the inverse. And suppose A is there, determinant A is minus 14, therefore it is invertible. Let B is equal to this and determinant value is 0, therefore it is not invertible. Remember that if the determinant value is 0, it is called a singular matrix. For non-singular matrix only, inverse exists. Inverse is defined. Well, let us go to the inverse of a matrix. If a matrix is A is non-singular, it is invertible, and the inverse is given by A inverse is 1 by determinant A into adjoint A. That's why I told you that adjoint A is useful for finding the inverse. This is obtained from the property of adjoint and a matrix. Anyway, A inverse is 1 by determinant A into adjoint A. 1 by determinant A into adjoint A. Well, let us find one question. Find A inverse, then show that A inverse is A square minus 3I by 2. Let us try now. For that, what is the step number 1? You have to find the determinant A, because the formula is 1 by determinant A into adjoint A. Therefore, I am expanding it with respect to R1, because R1 is having 1 0. 0 multiplied by a 2 cross 2 minus 1 multiplied by a 2 cross 2 plus 1 multiplied by a 2 cross 2. Therefore, I am getting the value now. I am getting the value of the determinant A as 2. I am getting the value of determinant A as 2. Well, now we are continuing now. We will try to now get the next step, that is adjoints. For that, I have to get the adjoint. I am showing you separately. For A11, it is plus multiply by a 2 cross 2 obtained by removing the row in which it lies, the column in which it lies. I have calculated also. Similarly, I am calculating A12. Check out. I am calculating A13. I am calculating A21. I am calculating A22. I am calculating A23. I am calculating A31. Calculating A32 and A33. It is plus sign obtained by removing the row in which that element 0 lies and column in which the 0 lies. It is 0 1 and 1 0 minus 1. This calculation to be done very slowly and to be done very carefully, because in one of the number is wrong, then you will get a wrong answer, and it is very difficult for you to check out which is where you have done the mistake. Therefore, it is always advisable to write this 2 cross 2 determinant, then do the calculation. Well, therefore, we are getting that a matrix which is called the cofactor matrix, which is directly writing minus 1 1 1 1 minus 1 1 1 1 minus 1. Now, what will be the adjoint? Adjoint will be the transpose of it. What do you mean by transpose? Change the rows into column, column into rows. I am getting it. First row converted into first column, second row converted into second column, third row converted into third column. And you are seeing that looking both are equal. No issue. Okay, well, now A inverse is very simple. 1 by determinant A, that is already we have found, that is 2. 1 by 2 into that. Okay. Now we have found A inverse now. It is not the question. We have to prove something. We have to prove it. A inverse is given now. A is already given. Let us find what is A square minus 3i. They want it now. Therefore, A square is nothing but A into A minus 3 into that. For I found it A square minus 3i. Very simple. I know product of two matrices. I know what is you mean by scalar multiplication. Therefore, when I found it as minus 1 1, 1 minus 1 1, 1 1 minus 1. But what is it actually? It is nothing but, if you divide both of them by 2, the right hand side is nothing but A inverse. Therefore, A inverse is nothing but A square minus 3i by 2. We have proved it. We found the A inverse and we have proved that it is nothing but A square minus 3i by 2. Good. Let us move on to question number 5. You have been given A as 1 tan x minus tan x1. You have to show that A transpose into A inverse is cos 2x minus sin 2x sin 2x into cos 2x. Is a problem involving both inverse and transpose. Well, let us now try to find A inverse first. For that I need a determinant. It is 1 into 1 minus of tan x into tan x. Therefore 1 plus tan square, which is nothing but secant square x. I am keeping it ready. Now I need adjoint. How to get the adjoint? Already we have seen. Change the place of minor diagonal and change the sign. Interchange and change the sign. Therefore 1 1 and minus tan x and tan x. Therefore what is A inverse now? 1 by secant square x into 1 minus tan x and 1. I am bringing that secant square x inside. When I bring it inside, all of you know that tan x is sin by cos and secant square is into cos square. For when I do this kind of calculations, I am getting A inverse as cos square x minus sin x cos x sin x cos x into cos square x. Now I got A now, and from that I am getting A dash, that is the transpose. I am multiplying both A dash and A inverse, that is A transpose and A inverse. I am getting it now. It's a normal multiplication. First row operated with the first column, first row operated with the second column, and so on. And after this I am getting these steps. And wherever I am having tan x, I am replacing it by sin by cos, and I am simplifying. I am getting sin cos square minus sin square, then minus sin x cos x minus sin x cos x, sin x cos x plus sin x cos x, minus sin square x plus cos square x. I know the formula. Cos square x minus sin square is cos 2x. 2 sin x cos x is sin 2x. I am applying it now. Therefore, I got the answer. A dash A inverse is cos 2x minus sin 2x into cos 2x. Here we have applied the idea of A inverse, we have applied the idea of transpose, and we have multiplied. Good. Well, success is dependent on efforts. All the best. Thank you.